These are notes from section 4.3, which is on definite integrals. What we're looking for is we're trying to find the area under a curve from point A, from our, that's not a very straight line, from our x value A to x equals B. Assume those are straight vertical lines. So we're looking for this area right here, the area between the x-axis and the curve, all of this area. And it can be found by integrating f of x dx from A to B. This is a representation of the area between the curve and the x-axis. Again, this is read as the integral from A to B of f of x dx. We do read it from the bottom to the top. The bottom is my starting bound on the left, the top is the ending bound on the right. A couple properties of the integral from A to B of f of x dx. The first one says the integral from A to A. So if the top bound and the bottom bound are the same, so if I have a curve, and here's x equals A, and I'm looking for the area under that curve starting at A and ending at A, if my starting and ending point are the same, notice there's no area under the curve. So if the top bound and bottom bound are equal to each other, the integral is 0. The second property says if I have the integral from A to B of f of x dx, and I add that to the integral from B to C of f of x dx, so I have the integral from A to B, so that would be the area from A to B. That would be all this area right here. And I add that to the integral from B to C, the area from B to C. I add those two areas together. Notice that's the same as the area from A to C. It's the same as the integral from A to C of f of x dx. The third property says that if I am adding or subtracting two functions inside the integral, I can split that up into two separate integrals. The integral from A to B of f of x plus or minus g of x dx is equal to the integral from A to B of f of x plus or minus the integral from A to B of g of x dx. Notice that works for addition and subtraction. It does not work for multiplication and division. Property 4 says the integral from A to B of f of x dx is equal to the opposite of the integral from B to A of f of x dx. So I can switch the bounds if I want, as long as I multiply by -1. Basically, let's suppose this is 2 and this is 7, and I know the area from 2 to 7 is 15. If it asks me what is the integral from 7 to 2 of that function, 7 to 2, I'm going backwards. Notice my bound on the bottom is bigger than the bound on the top. I would say that that's equal to, I can switch those bounds. I can go 2 to 7, as long as I multiply by -1. And the area from 2 to 7 is 15. So the integral from 7 to 2 is -15. And the fifth and final property that we're talking about today says the integral from A to B of any constant times f of x dx. I can take that constant, I can move it out front. So it's equal to k times the integral from A to B of f of x dx. Notice that's only true if k is a constant. If I have a variable, you cannot take a variable and move it out front, but you can move a constant out front. One more thing we need to talk about here, it's not really a property written out like this, but it's important to know that area below the x-axis has an integral that is negative. We never really say the area is negative, but the integral would be. So if, let's go back to our 2 to 7 example here. If I know that that is 15, that area there is 15, the integral from 2 to 7 of f of x dx. Remember, it's always the area between the curve and the x-axis. Well, because that area is below the x-axis from 2 to 7, that integral would be negative 15. Now, the question always comes up, what if it's both below the x-axis and we're integrating backwards from 7 to 2 like we did earlier? So it wants the integral from 7 to 2 of f of x dx. And we're looking at this f of x right here. Well, I've got the bigger bound is on the bottom here. I want to switch that. I'm allowed to do that as long as I multiply by -1. Integral from 2 to 7 of f of x dx, we just said was negative 15. And I get positive 15. So if you have area that's below the x-axis, it's negative. If you integrate backwards, it's negative. And if you have both, well, negative and negative, it's not going to be positive. A couple examples here. The first one's pretty basic. It gives us two integrals. It tells us that the integral from 0 to 5 of f of x dx is equal to 10. And the integral from 5 to 7 of f of x dx is equal to 3. And basically, I don't know what the graph looks like, but I do know the area starting at 0 and going out to 5, I have 10 square units, and from 5 to 7, I have 3. Part A asks us to evaluate the integral from 0 to 7 of f of x dx. From 0 to 7, I have a total of 13 square units. Part B wants the integral from 5 to 0 of f of x dx. This is one, I've got the bigger bound on the bottom. I think it's always easier to change it so that the bigger bound's on the top, which we're allowed to do as long as we take the opposite. The integral from 0 to 5 was given to be 10, so I get negative 10. Part C asks for the integral from 5 to 5 of f of x dx. That is using, what was it, the second part, the very first property we looked at here. If the two bounds are the same, top and bottom bound, the area from 5 to 5, there's no area if I don't go to the left or right at all. And part D asks for the integral from 0 to 5 of 3 times f of x dx. This 3 is a constant. I can take the constant and move it out front. And then the integral from 0 to 5 of f of x dx was defined to be 10. So I have 3 times 10, which is 30. Easy enough. These next problems are a little bit more complicated. We are given a graph of g of x, and it's asking questions about the integral of g of x on various intervals. Make this a little bigger so it's a little bit easier to see. Maybe. All right, so part A asks us to evaluate the integral from -10 to -6, -10 to -6 of g of x dx. So -10 is right here, -6 is right here. So I'm looking for this area right here. notice I've got all straight lines. Problem like this would say that this is a semicircle right here. So right now, the only way we know how to do this is because we have straight lines and circles or semicircles. We can just use geometry to find that area. We can do it one of two ways. We can either split it up so we have a square and a triangle and find the two areas, add them together. Or we could recognize this is a trapezoid and use area of a trapezoid to find that area. So I've got 1/2 sum of the bases. This base is 4 units. This base is 3 units. 4 plus 3 is 7. And the height is 3. So I get 21 over 2. Because that area is below the x-axis, it is negative 21 over 2. Part B asks us for the integral from -6 to 1, -6 to 1 of g of x dx. There's -6 all the way out to x equals 1. That is a triangle. Area of a triangle, 1/2 base times height. The base of this triangle is 7 units. The height of the triangle is 3 units, so 1/2, 7 times 3 again, 21 over 2. And it's above the x-axis, so it's positive. Part C wants the integral from 1 to 5. Integral from 1 to 5 would be the area under this curve here, which is a half circle. Area of a semicircle would be 1/2 pi r squared. The radius of this circle is 2 units. You get 2 pi. And finally, part D. Part D asks for the integral from 10 to 5. The integral from 10 to 5 of g of x dx. Well, 10 to 5, it's going backwards, so I'm going to switch it. We're going to go 5 to 10, which I can do as long as I multiply by -1. So I need the area from 5 to 10. That is a trapezoid again. Area of a trapezoid is 1/2 the sum of the bases. 1, 2, 3, 4, 5 units for that base. 1, 2, 3 units for that base. 5 plus 3 times the height, which is 4 units. So the integral from 5 to 10 is 16 because it's below the x-axis. It's -16. But I also had that negative out front here because I switched the bounds. So I get positive 16. Those are the notes for section 4.3. If you are having questions on anything, please let me know, reach out.